Okie dokie. All right, function operations. All right, this is kind of what you're going to see today, okay? You are going to be given a couple of functions. And again, in review, we talked about this. We said that these functions have names. And up there, as you see, we've got one function that is labeled f, hence f of x. And we have another function that is named g of x. So that's how we're going to distinguish between the two functions, okay? F of x is x squared minus 3x plus 2. G of x is equal to 2x minus 4, okay? Now, find, and here's what they want you to find. The function f plus the function g, they want you to take these two functions, add them together, and then evaluate them for a value of 3. So more or less what that is telling you to do, what this is telling you to do is let's take these two functions, let's add them together and see what that creates, and then let's plug a 3 into it and see what number it spits out, okay? So here's what we're going to do. We're going to take the f function. We're going to take that function and we're going to add to it the g function. That's what this is telling us to do, f plus g. Please take the f function and add the g function to it. Okay? Now, with addition, remember, addition does not change anything, okay? It's not like subtraction. It's not like a minus sign that will tend to change some signs. So addition isn't going to change any signs up here. So more or less what we've got here is I'm just going to drop the parentheses. Everything really just kind of stays the same sign-wise. Which terms up here are like? Which terms am I going to be able to combine? Negative 3x and 2x, okay? Does everybody agree that x squared is unique? X squared is unique, right? X squared is unique, so we're definitely going to have x squared. What is negative 3x plus 2x? Negative 1x, good. Negative 3x plus 2x is negative 1x. We are just simply combining like terms. What else is like? I agree. And what is 2 minus 4? Negative 2. Good. Negative 2. So if we take the f function and we add the g function to it, this is the function that results. Okay? Is everybody okay with that? Okay? That's kind of step number one. What do they want us to do? Add the two functions together. We did that. We've got x squared minus x minus 2. The second part to this is now going to be taking this 3, and we're going to go plug that 3 in for those x's. We are now going to evaluate this function for a value of 3. So we're going to plug 3 in. And again, I would highly encourage you to use parentheses whenever you replace a variable with anything. And we did quite a bit of that last week. So we plugged the 3 in. Guys, what's 3 squared? 9. Minus 3 minus 2. What's 9 minus 3? 6. And 6 minus 2? Boom, 4. That's what we're after. Once we add the two functions together, we evaluate that result for a value of 3. So 3 goes in, 4 comes out. Guys, functions are input-output machines. Okay? Hurry. Okay, any questions? Everybody good with that one? Got it down? Nelson, you look so excited. Good job. All right, let's do another one. Okay, go ahead and jot that one down. It's going to be a slightly different look. We'll talk about it when we get there. Very similar type start, though. You're given a function f, you're given a function g. There's the two functions and how they're defined. Now, if you notice, down here with the find part, this looks a little bit different than the previous example. Now, this time, this one is basically saying, hey, go to the f function and evaluate that for 3 and get an answer. Go to the g function, evaluate that one for a value of 3 and get an answer, and then I want you to subtract the two results. So that's basically what's going on with this one. So this time, we're going to take f of 3, and we're going to go to the f function, and we're going to put a 3 in wherever we see an x. So here's what that's going to look like. We're going to go 3 squared plus 5 times 3. Told us to go to the f function, put a 3 in wherever we see an x. We just did that. Guys, what's 3 squared? And what's 5 times 3? And what's 9 plus 15? 24. So if we put a 3 into the f function, 24 comes out. Okay? Everybody good with that? Okay, just like we did the other day. Then we're going to take a look at g of 3. Now we're going to go to the g function, and wherever we see an x, we're going to put a 3 into that one. So we are going to... Yeah, I'll look for it here in a minute.
It's right there behind me.
Is it really? Oh, there you go. Thank you. Good job, Ellison. Let's put a 3 into the g function right here. Here we go. We're going to go negative 3 times 3 minus 2. We are now putting a 3 into the g function. Negative 3 times 3 minus 2. Negative 3 times 3? Negative 9 minus 2. Beautiful. Negative 11. Go to the f function, put in a 3, out comes 24. Go to the g function, put in a 3, out comes negative 11. What do they want us to do with these two results? They want us to subtract them. So it is going to be 24 minus negative 11. 24 is what the f function gave us. Negative 11 is what the g function gave us, and we are subtracting those two values. Now note the minus and negative here. Guys, what's going to happen right there? That becomes a plus. 24 plus 11? 35. Boom. 35, final result. Okay? So this time you are being asked to evaluate each function for a particular value. Coincidentally, it was the same value. Okay, no big deal. Okay? We evaluate the f function, got a result. Evaluate the g function, got a result. We subtracted the two results, come out with 35. What do you think? Any questions? Everybody okay with where all that came from for now? Of course, you're going to get a chance to practice. Looking forward to it. I'm sure you are. It's okay. There you go. There you go. All right. Now, are we good? Okie dokie. Okay, let's go to the next one. Let's go to the next one. Very similar to the first example. Again, we've got a function named f, we've got a function named g. There's how those two functions are defined. Now, on the find part of this one, this is where this one's maybe just a little bit different, okay? What they want us to find, what are they wanting us to do with the two functions? Subtract them, right? Take the f function, let's subtract the g function. Now, you notice in this little set of parentheses, okay? It's just an x, all right? They're not going to have us evaluate that result for any particular type of number. So whenever they ask you to operate on these functions and all they give you in that little set of parentheses is an x, that means you're just going to, in this case, we're just going to subtract the two functions. We are literally going to take x squared plus 6x minus 5, and we are going to subtract off negative 4x minus 4. And once we do that, we're going to be done. They are not having us evaluate this for a particular value. They are more or less saying, hey, would you please just subtract these two functions for me? Let's get a resulting function, and then you would be sitting, waiting, going, well, what else do you want me to do with it? Well, right now, they're not going to have you do anything else. Okay? Be careful with subtraction. Okay? Be careful with subtraction. We are subtracting off the g function. Okay? Please remember, a minus sign in front of parentheses is going to change the signs of everything inside this second set. Okay? So what I'm going to do here, I'm going to rewrite this. And I'm going to circle my sign changes. That minus sign is going to make negative 4x positive 4x. That minus sign is going to make negative 4 positive 4. And I circled those signs. That way I know that I changed them. Okay? If I have to go back into my work, at least I know what I changed. But be careful with subtraction. Is everybody okay with that? What you got? Pardon? Why? Because of this minus sign. Minus a negative 4x, minus a negative becomes a positive. Minus negative 4 here as well is going to make that a positive. A minus sign in front of parentheses will affect all the signs behind it. Okay? Just be careful with subtraction. Anytime you see subtraction, just be a little more cautious. Now, let's go collect like terms. Are there any other x squareds anywhere? There's not. So we're going to stick with, I'll do this one a different color. We're going to stick with x squared. What am I going to combine with 6x? 6x plus 4x. So 6x plus 4x would be 10x negative 5 plus 4, which would be what? Thank you. Negative 5 plus 4, negative 1. And that's where we're going to stop with this one. They did not, right there, when they put that x right there, they're just saying, hey, would you please just operate on these functions? We did that. There's our resulting function once we subtract. We don't need to evaluate for a particular number. Hey, we're done. X squared plus 10x minus 1. So I don't know. Might think that might be easier just because we don't have to have that extra step of throwing a number in there. Okay? We okay with that? Questions before we go to the last example? Okay. All right, here we go. Last one. Very similar. I think you'll notice this one's very similar. And once we get to a certain point, I'll kind of tell you why this one's a little bit different, just to kind of be a heads up, because I think you're going to get one or two of these on the assignment today. So I wanted to make sure you had an example. Again, we've got a function named f. We've got a function named g. They've defined those functions for us. Again, they are asking us to subtract the two functions. We're going to do the f function minus the g function. okay? So again, just like I did on the last one, I'm going to go ahead and go x squared plus 6x minus 5 minus now the g function. And again, they are not going to have us evaluate this for any particular number. So once we do the subtraction, hopefully we'll do it properly, we'll be done. Minus sign is going to affect all signs behind it. Okay, so that minus sign right there is going to change. So x squared plus 6x minus 5 plus 4x to the third minus x. Try to make sure that we make the appropriate sign changes. Is everybody good with where everything has come from at this point? Everybody okay with that? Now, here's where this one's a little bit different, okay? Again, it's kind of basic. We're looking for like terms, okay? What term has our largest degree? Let me throw that term out there again. Which term has the largest degree? Okay, good. 4x to the third. Remember, degree is tied to exponents of variables. Your largest exponent here is a 3, okay? Now, I would encourage you to always try to write these in a standard form, meaning largest degree to smallest. I think that's just good practice. Are there any other x cubed terms? There's not. So 4x cubed probably needs to be our first term. We're done with that one. What's our next highest degree? X squared. How many of those are there? Just one, right? So we have positive x squared. That one's done. Are there some x's we can get together? How many total? How many? Well, there are 2, so together 6x minus 1x would total 5x. Good. Boom. Got it. And then what's the only thing left? Minus 5. Okay? So just make sure when you go collect these like terms and you're trying to bring everything together, okay, it's going to be okay if you end up with some terms that are unique. Okay? We had a third degree term that was unique, a second degree term that was unique. We were able to combine some x's, got that, and then we had a unique constant term. Okay? So that may happen. Be careful about that. Make sure that you are only combining things that are truly like. Okay? And again, I would try to write it in standard form, biggest degree to smallest degree if you can. If you don't, it's not necessarily wrong, but come multiple choice test or something like that where you're looking at options, they're probably going to have things in a nice standard form. Okay? But guys, that's really all we're doing today. We're just doing some basic operations on functions, some addition, some subtraction. Some of them you will evaluate for a value. Some of them you won't, as we've seen the last couple of examples. Okay? But we need to be familiar. Again, the familiarity is just knowing what you're dealing with. Okay? Do you know what to do with the functions? Do we know how to combine the functions? And if we can get somewhat comfortable with that, then I think we're making pretty good progress. Okay? Like I said, Wednesday we're going to do some composite functions, which means functions within functions. So that's real exciting. I think you'll have our time sleeping between now and Wednesday before we get that lesson. So it's all good. Okay, everybody good? Questions? Okay, all right.